Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for Math 152 in regards to frequency distributions and finding relative frequencies within those distributions. I'm working off of the Chapter 2, Section 2 homework in my Stat Lab, question number 5. I'm also using the course notes that are on Moodle for Chapter 2, Section 2 as a guide. There is an example here on the notes. It is different than the problem that we're doing, although it revolves around the same mathematical concept. This is just a different data set. Okay, so this particular question asks us to find relative frequency. So construct a table of relative frequency based on the frequency distribution shown below that compare tar in non-filtered and filtered cigarettes. So if you click on the icon, then you will actually get the frequency distribution, and then we want to find the relative frequency essentially in each class. And you have this split up into both non-filtered cigarettes, so tar in milligrams, and filtered cigarettes, also tar in milligrams. Okay, so let's go to the notes and just look at what a relative frequency is for a class, and that is essentially the percentage of all of the data points that belong to each specific class. So to find the relative frequency, we take the frequency for each class, so the number of data points that belong to the class, divided by the sum of all the frequencies, which is basically the total number of data points that you have. When you divide that, you'll get a decimal, times it by 100 to make it into a percentage, which is, also easily accomplished by just moving the decimal to the right 2 places. And when you're done, you can check yourself. All of the relative frequency percentages should sum to 100%. And that's kind of a way that you can check yourself. So, alright, so let's look at doing non-filtered first. And so the first class is 2 to 7. So if I look at the frequency distribution here, notice that I do not have any class that is having tar between 2 and 7 milligrams for non-filtered cigarettes. So then basically the frequency for that is 0. So then the relative frequency percentage would also be 0. Notice we also, for non-filtered cigarettes, do not have any data points that belong to the class 8 to 13 milligrams. So that's also going to be 0%. And then once we get to 14 to 19 milligrams of tar, we have one data point that is in that class. So we can indeed find a percentage there. So if I sum up all of the data points for non-filtered cigarettes, essentially adding up all of these numbers here, all right, I get 25. So basically I've got 25 data points. So that should be the denominator. So if I do 1 divided by 25, and that's 0.04 times it by 100, I get 4%. So that goes here. Okay. I have 0 data points in the 20 to 25 class, so that would be 0% again. 16 data points in the 26 to 31 class category. So then 16 divided by a total of 25 data points gives me 0.64 or 64%. and 7 divided by 25, which is the next class, right, is 28%. And once again, 1 divided by 25 is going to be 4% again as well. And so we could check ourselves, right? If I add up all of these percentages that I just found, should total to 100%. And it does. So that's the way we can check ourselves. Okay, so now let's do the same thing for filtered cigarettes. And so let's first of all find the total number of data points for filtered cigarettes. So we're going to add up these numbers here. So 1 plus 2 plus 5 plus 17. We also have 25 data points in the filtered cigarette distribution. So we basically do the same thing to determine those percentages. So class 2 to 7 has 1 data point in it. So 125, once again, 4%. The 8 to 13 class has 2 data points in it. So 8%. 14 to 19 has 5 data points in it. So 20%. 20 to 25 class has 17 data points in it. So 68%. And then notice we do not have any data points in these classes here. So then these would all be 0. So let's check our answer. Okay. So that's how we get the relative frequency. So then it says, hey, do cigarette filters appear to be effective? And so if we look at our relative frequency, we notice that our percentages here for filtered cigarettes seem to belong to the classes that have lower amounts of tar, which is what you would imagine, right? That's kind of the idea of what a cigarette filter does, as opposed to non-filtered, where the majority of these percentages are in classes that have higher amounts of tar, right? So that would give evidence that the filters would appear to be effective. So I think we're looking at C, yes, because the relative frequency of the higher tar classes is greater for non-filtered cigarettes, and that's pretty much what we're seeing here. Okay. Hopefully this video is helpful in finding relative frequency in frequency distributions. Have a great day.